Alright, so this is question 9 in chapter 18. So here's the given diagram, and when I first looked at this given diagram, I just got really sad because it looks so complicated. But then I realized if we rearrange some of the resistors and some of the branches, we can get like a more simple and familiar drawing. So here's a more simple diagram. It's the same thing as the one above, just like redone. And the first thing I noticed is that there are two resistors in series. So I wanted to add these resistors in series and combine them, and when I combined them, I got that this whole branch had a combined resistance of about 25 ohms. So here's the next diagram, and as you can see, there are three resistors in parallel. And if I add these resistors in parallel up using the like fun little reciprocal formula thing we got in class, I get that these three resistors in parallel combine to about a resistance of 2.941176 ohms. So here's the simplified diagram of that, and as you can see, there are two more resistors in series that we need to add up. There's a 10 ohm resistor and a 2.941176 ohm resistor, and when we combine these two resistors, we get a combined resistance of about 12.941176 ohms in the entire like circuit. So here's the like completely simplified diagram of a circuit. So I did part B first because when I tried to do part A first, I just got super confused. So the first thing I'm going to do is consider the entire circuit, like find the current running through the entire circuit. So when I use I is equal to VR, I get that the current is about 1.931818 amps. But that's not what we want, right? We only want the current going from point A to point B. So if you think about it, we know that the current going through this 2.941176 ohm resistor and the 10 ohm resistor is going to be the same because they're resistors in series, right? So the current going through them has to be the same. So if we do I is equal to VR again, only considering the points from A to B, we know that the current has to stay the same, but the resistance is different, right? So we're going to plug in the resistance of only this 2.941176 ohm resistor because we're only considering point A to B. And when we do that, we can solve for the voltage from A to B, and we get that the voltage is about 5.68182 volts. Alright, so now we're going to do part B. So if we look at part B, we know that the voltage going from point A to point B is about 5.68182 volts. So here's point A to point B, so we're just going to consider that part. So I redrew that over here. And we know that each little branch is going to get the same amount of voltage because remember the voltage kind of falls like a current, or like what is it, like the river thing that we watched in the video. So each branch is going to get the same amount of voltage. And so each branch is going to get about 5.68182 volts. And we also know that the current going through the 20 ohm resistor and the 5 ohm resistor is going to be the same because the resistors are in series. So we're just going to find the general current in that branch in order to find the current going through the 20 ohm resistor, which is like kind of the goal. So when we solve for I using I is equal to V over R, we get that like the current going through the branch is about 0.227273 amps. And each resistor is going to get that amount of current. So the 20 ohm resistor is going to get 0.227273 amps. So that's our answer. Yay.